So for this one, we need to calculate the resistance in the wire first. For part A, we're going to use the formula resistance is equal to the resistivity times the length of the wire divided by the area. Now the resistivity is given as 3 times 10 to the minus 8 ohm meters, and the length of the wire is given to be 1500 meters. We're not given the cross-sectional area, but we are given the diameter. So to calculate the area, we can use pi times the radius squared, or if you'd rather, we can use pi times the diameter squared over 4. Right, so either pi r squared or pi d squared over 4. Those are equivalent ways to calculate the area. Either way you do it, you get 196 times 10 to the minus 5, 1.96 times 10 to the minus 5 square meters. So when you plug all that in and calculate the resistance is 2.3 ohms for part A. Part B, we're given a potential difference and asked to calculate the power. So the formula we have for power dissipated is, well, you can use a variety of formulas here. I think the easiest one to use is delta V squared over R. Okay, and that's 120 squared divided by 2.3, which is 6,300 watts. Now, I kind of prefer, when we're talking about power dissipated, to use the formula I squared R, for reasons we get to when we talk about alternating current circuits. But you know, in Ohm's law, the current I is equal to delta V over R, and this is true for direct current circuits. So if you plug that into I squared, you end up with delta V squared over R, so it really doesn't matter which formula you use in this case. For part C, we're asked to find how much money does it cost per day to maintain the wire. So, and they give you the cost of energy. So we need to find energy. We need to solve for energy. And our formula for energy, the relation to power, is that energy is equal to power times time. Now the power we're given is 6,300 watts. That's 6,300 joules per second. So that's already in MKS units. And the time is 1 day. Well, okay, we got to convert that into MKS units, which is seconds. So there's 24 hours in a day, and there's 3,600 seconds in an hour. So that's 86,400 seconds. Okay, so the total energy we're talking about is the power 6,300 joules per second multiplied by 86,400 seconds. That is 5.41 times 10 to the 8th joules. But now we got to convert that into kilowatt hours and cents and so forth, right? So, of course, 1 kilowatt hour, that's a unit of energy. Kilowatt hour is 3.6 times 10 to the 6 joules. That's for your formula sheet. But we're also given the relationship that money equates to energy in this case, where 14 cents is equal to 1 kilowatt hour. So I'm basically going to convert this energy into money. I'm going to take 5.41 times 10 to the 8th joules. I'm going to convert it into kilowatt hours. Okay, that's 150 kilowatt hours. And then I'm going to take that 150 kilowatt hours and convert it into money by multiplying by 14 cents per kilowatt hour. And that's 2,103 cents, or $21.03. That's an expensive wire to maintain.